Hello grade 11s, my name is Gillian and today we are having a lesson of physical science. We are going to delve into the big ideas around the types of reactions, and the specific type of reaction that we're going to be looking at today are those that happen in aqueous solution, in other words, in water. Let's look at our screen and we can see our definitions there of solvent, solute, homogeneous, solution. We need to add another one, which is insoluble, and one which we will be looking at in more detail is electronegativity. So, what makes water such a versatile solvent? A solvent is something that will dissolve a solute. So we have a water molecule here. We have oxygen that is connected to one hydrogen on this side and another hydrogen on that side. Now, atoms have a particular electronegativity. Electronegativity is how strongly an atom will draw the bonded electron pair in a bond. So this line on this diagram represents the bond between oxygen and hydrogen. This is a covalent bond. You will remember that a covalent bond is the overlapping of orbitals so that unpaired electrons can share the orbital, and then both atoms are happy because they have a paired electron that is shared, well, the paired electrons are shared in that orbital. So electronegativity, this big word here, tells us how strongly one of those atoms will draw the electron pair towards itself. Now, oxygen is very electronegative. It likes to have those electron pairs towards itself. And so the electron cloud will hover over the oxygen. That makes the oxygen slightly negative. We say that it is polar. It's a polar molecule. And the symbol we use for that is delta, like that. Delta negative, because the electron cloud is pulled over the oxygen atom. Now that delta sign, you might be a little confused because we've used delta before. We use delta as in a triangle. It is the Greek letter delta. This triangle was used for change in, and it is the capital letter for delta. This delta that we're using here to denote the polarity of the covalent molecule is the small letter for delta. It's the Greek letter. So what happens to the hydrogen? Well, the hydrogen doesn't get as much of the electron cloud around it, and so the hydrogens become slightly positively charged, so delta positive. So this water molecule, which is a polar molecule, is an incredibly versatile particle, molecule, because it has these poles attached to it. We have looked at the covalent bond. There's the covalent bond, which is the sharing of unpaired electrons. What happens with an ionic bond? Well, the ionic bond, the particles, the difference between the electronegativity of them is so great that they can't share the electrons anymore. An electron is actually given to one of those atoms to form ions. So in the ionic bond, we have ions being formed, and those ions are then either positively charged, which is then called a cation. So cations are positively charged ions, and anions are negatively charged ions. There is an attraction then between the cation and the anion. It's called an electrostatic attraction, and we get what is called a salt or a compound. So a salt or a compound is the result of an electrostatic attraction between a cation and an anion. So what does hydration look like? Well, what is it microscopically? Well, we have a salt in water, so an ionically bonded substance, a compound. It consists of a cation, in this case it's copper sulfate. The cation is copper 2+, and the anion is the sulfate ion, SO4 2-. So because we have water particles that are polar, the oxygen is slightly negative, the hydrogen is slightly positive. They will align themselves, these water molecules will align themselves to attract the sulfate ion and the copper ion. And that attraction is so great that these particles are pulled away, these anions and cations are pulled away from the salt, and that electrostatic force between the ions is broken. In solution, this is what it looks like. The cation is completely surrounded by water particles, and the anion is also completely surrounded by water particles. So they cannot reconnect. So what is an insoluble salt? An insoluble salt is where the electrostatic forces between the cation and the anion are so great that the water that is trying to attract the cation or anion can't break it apart. So the electrostatic force is too strong. That is what makes an insoluble salt. An ionic salt or compound dissociates. The big word is dissociates in water. You need to know this terminology. Here's an example. We have a salt magnesium nitrate, and it dissociates into magnesium 2+ ion and the nitrate 3- ion. They are aqueous. That means that they are now surrounded by water particles and they are in the aqueous form. You can see that the salt begins as a solid. Let's try it out with the sodium chloride that we have. We are adding water in the liquid form, and it will dissociate, the solid will dissociate into the cation, which is sodium, and the anion, which is the chloride ion, and that is going to be aqueous. So that is an example of how we change the compound into its component ions and how we write the equation for that. Now, a covalent molecule ionizes in water, so you need to know that word. It's different because we're talking about a covalent molecule. Now, in this case, the molecule, the covalent molecule, reacts with the water, whereas with the compound it does not. All the water does with the compound is it draws the ions apart. In this case, the ammonia is going to react with the water, and we get the ammonium ion in aqueous solution and the hydroxide ion, there it is there, the OH- ion, which is in aqueous solution. So let's try this out with an acid. This happens, ionization happens with an acid and with ammonia. So we're going to add water. Water takes part in the reaction. And we form now what is called the hydronium ion. It's an H3O+ ion that is specifically named the hydronium ion. You need to learn it. And what is left behind then is the chloride ion, which is aqueous. So you can see there that the hydrogen of the water is part of the reaction. It forms part of that hydronium ion. So what is the dissolution process? There's another big word for you. Well, two things. An ionic solid breaks up to form ions. So that's talking about the ionic solid, or a covalent molecule, and we're speaking about acids and ammonia, form ions with water. Our last idea, what is conductivity? Well, when electricity is conducted in a wire or in a solution, we speak about conductivity. So if we have enough ions in solution, then electricity can flow through that solution. So an electrolyte is the name of a solution that can conduct electricity. It is a liquid. There are free ions in the solution, and it has the ability to conduct electricity. That is what an electrolyte is. The greater the number of ions present in a solution, the greater the conductivity will be. So if we increase concentration of ions in solution, conductivity is going to increase. This is not true for all ions. So for example, for a sugar solution, sugar does not conduct electricity. So we have to be a bit particular and careful about what we learn about what conducts electricity. Right, I think we've had enough for now. We're going to take a quick break. Welcome back, grade 11s. Just to remind you, I am Gillian. We are in a physical science lesson. We are discussing chemical change and specifically reactions in aqueous solutions. We have discussed what is hydration, what is dissociation, what is ionization, and what does conductivity look like for ions in an aqueous solution. So now we're going to focus on the ion exchange reactions that happen in aqueous solution, and specifically we're going to look at precipitation and forming precipitates when we put two solutions together. This is something that you really do need to learn. It is the solubility rules. You need to know them. So, all group 1 salts and ammonium salts are soluble. So group 1 metal salts, that would be potassium, sodium. Group 1 metal salts and ammonium salts, ammonia looks like this, NH3, and when it's in its ion form, it looks like this, NH4+. That's the ammonium ion. Those are soluble. All nitrate salts are soluble. So nitrate is NO3-, that's the ion, NO3-. When it makes a salt with a metal, it will be soluble. All halides are soluble except, so have a look at these exceptions. Silver. So when we have a silver halide, when we have a lead halide, and when we have a mercury halide, those are going to be insoluble. In other words, they are going to form a precipitate. All sulfates are soluble except for barium, Ba, lead again, Pb, and mercury. So those three exceptions, those sulfates are insoluble. Then, all carbonates are insoluble except for group 1 carbonates. So we've spoken about the group 1 already. Group 1, those metals, when they bond to carbonates, they will form a soluble salt, and then ammonium carbonate. A carbonate is CO3 2-, that is the ion. So what is a precipitate? The precipitate, the word precipitate, is the word to describe an insoluble substance that is formed in a solution during an ion exchange reaction. I have an example here for you. Barium chloride. Barium chloride, there we go. There it is. It's in aqueous, so it's in a solution already. It's been dissolved. And we add to that silver nitrate. So the nitrate is soluble. So all nitrates are soluble. Now, if we look at the products, you'll see that silver chloride is a solid and it is one of the products. So how does the silver chloride form? Well, the chlorine or the chloride reacts with the silver. So we have an exchange of ions with these substances. The leftover ions will be barium, there's barium, and nitrate. And so they form barium nitrate, which is also soluble because it is a nitrate salt. So you can see that there that it is aqueous. How do we show in an equation that we have a precipitate being formed? There is an arrow, it's a downward arrow, and that downward arrow tells the person who's looking at your equation that a precipitate has formed. It is an insoluble salt that is a result of an ion exchange reaction. This is really useful for us because it helps us test for what kind of anions we have. An anion is a negatively charged ion. We can't see often what we have in solution. It is a translucent solution, it is clear, we can't see what is inside the solution. So when we have a known precipitate, we can add that substance to our unknown, and if we get a precipitate, we will then figure out what we have in the unknown solution. So the ion exchange reaction allows us to form precipitates, which then tells us what our unknown is. So here we go. How do we use this information to figure out what we have? So we've got an unknown solution, we don't know what's in it. Let's add silver nitrate. Silver nitrate because the nitrate is soluble. However, we know that silver gives us a precipitate with some ions. If a precipitate forms, it could be a halide ion or it could be a carbonate ion. Interestingly enough, they could both be white in color. So then how do we distinguish between the halide ion and the carbonate ion? Well, carbonate is an interesting salt because it responds to an acid. And what happens is when an acid is added, it will disappear. The precipitate will disappear because carbon dioxide is formed and water and a new salt is formed. So on to our halide. Halides have got very distinguishable colors. Silver chloride is white, silver bromide is cream, and silver iodide is yellow. Now there are other precipitates that are white too, so that's where it gets tricky. We have to know our chemistry. Barium sulfate is white in color, barium carbonate is white, and silver carbonate is also white. So how are we going to work this one? Is it a carbonate or is it a sulfate? Barium is what is going to give us a precipitate, a white precipitate. So if we have an unknown solution, we don't know whether it's a carbonate or a sulfate, we're going to add barium nitrate because the nitrate is soluble. A white precipitate forms. It can either be a carbonate or it can be a sulfate. What's the trick? To distinguish them, we need to add the acid, the nitric acid, and the reason why we use nitric acid because the nitrate is soluble, it's not going to interfere in the production of precipitate. With the carbonate, it's going to disappear, so this one will disappear, forming the gas, where the sulfate will remain. The sulfate is going to remain. So how do we write equations for these precipitation reactions for a carbonate and for a sulfate? So let's have a look on the board. We are going to start with sodium sulfate, and that's aqueous, right? Because it is dissolvable in solution in water. And barium nitrate, also dissolvable. We have an ion exchange, and so the sulfate will displace the nitrate and we get a precipitate being formed, and so that will be barium sulfate. It is a solid, it is a precipitate, so I put an arrow like that. And what is left over? Well, it's going to be the sodium and it is going to be the nitrate. And because the sodium is a plus ion and the nitrate is a minus ion, they will bond in that ratio, and there are two of them, so it is now balanced. You can see there's a 2 there and a 2 there. For our carbonate, I'm just using an X to replace a cation, and then we're going to add the barium nitrate. Again, you'll see that this carbonate is going to take the place of that nitrate. It's an ion exchange reaction, and so we have barium carbonate, which is being formed. It is a precipitate. We'll see it. It is white. And what is left over? Well, it's going to be the X, and it's going to be the NO3. Right. That is how we write equations for these two reactions. I hope, grade 11s, that has given you some insights to the big picture around reactions in aqueous solutions.